11.3, maxima and minima problems. Hit pause, make some notes. When you're ready, hit play. And we're going to look at using differentiation to calculate the maximum and minimum values of displacement, velocity and acceleration. Okay, so here's our example. Child's playing with a yo-yo. Yo-yo leaves the child's hand at time t equals 0, travels vertically before returning to the child's hand. The distance s of the yo-yo from the child's hand is given by this formula. S equals 0.6t plus 0.4t squared minus 0.2t cubed. And t is between 0 and 3 seconds. A, we've got to justify the restriction of 0 to 3. And B, we've got to find the maximum distance of the yo-yo from the child's hand to 3 significant figures. Okay, so in order to justify the restriction, I need to know what this graph looks like. So first things first, I'm going to sketch this graph. Now in order to sketch the graph, I need some useful coordinates. Most useful coordinates I can think of are the roots of the graph. So we got S is equal to 0.6t plus 0.4t squared minus 0.2t cubed. Now to calculate the roots, I'm going to set s equal to 0. When s is equal to 0, I've got 0.6t plus 0.4t squared minus 0.2t cubed is equal to 0. Now these are not nice numbers to deal with, but I can see if I multiply them by 5, I get much nicer numbers. 0.6 times 5 gives me 3t, plus 0.4 times 5 gives me 2t squared, and 0.2 times 5 gives me 1, so I get minus t cubed equal to 0, which are much nicer numbers. Okay, so now I can start to factorize this equation, and I can see that t is common to all three terms here. So if I factorize, I got 3 plus 2t plus 2t minus t squared, all multiplied by t, is equal to 0. And in the brackets I can factorize 3 plus 2t minus t squared. I got 3, factors of 3 are 3 and 1. And I've got t squared, so it's going to be a t and a t there. Now it's a positive 2t, so it's going to be 3 times t is going to be positive, and minus 1t. So that implies then that either t is equal to 3, t is equal to minus 1, or t is equal to 0, which is enough for me to sketch the graph. Okay, I've had to sketch the graph first because I kept drawing these very wonky lines. So let's mark on there what we know. When s is equal to 0, we got t equals 3 over here somewhere. We got t is equal to 0, and we got t equals minus 1. Okay, so in order to sketch our cubic, we've got to look at what happens as t tends to infinity. So if t tends to infinity, what happens to s? So as t tends to infinity, going that way, we've got t squared and t cubed. They're all positive, however I've got a negative t cubed here, so s is also going to tend to minus infinity. Which means that as t goes to infinity, s is going to go to negative infinity, so it's going to be going down this way somewhere. And as t tends to minus infinity, so going towards the left of the graph, what happens to s? Well, we'll have a negative infinity here, we've got a negative infinity squared here, which will be positive. But here we've got negative infinity cubed, which is what we're concerned with. It's negative infinity, but because we've got a negative here, it's going to be positive. So that's going to be, s will tend to positive infinity. So, as s tends to negative infinity that way, s is going to tend that way. So that's what our graph looks like. So it's telling us that it, if I can sketch this, it goes down through here, and we got a turning point, up through there, got another turning point, and it heads down through there. Okay, it's not the best, it's not the worst graph ever. Right. Okay, so the graph is telling us a story here. We know that time cannot be negative, so we can't have negative t. So it's got, and we're told that the yo-yo leaves the child's hand at time t equals 0. So we're starting off at 0 here, and it travels up to a turning point, and then it comes back and it hits displacement at 0 here. We can't have negative displacement, so that's why we have our time restriction between 0 and 3. So that's that justifies our time restriction. So our time is less than or equal to 3 and greater than or equal to 0, as we cannot have negative time and we cannot have negative displacement. Okay, hit pause, make some notes, and then we'll look at part B. Okay, so for part B, we've got to find the maximum distance of the yo-yo from the child's hand to 3 significant figures. It's important to note that 3 significant figures because that's that could be equivalent to 1 mark. Now, by symmetry, when it leaves the child's hand, it travels up through a turning point and back down to 3. And I said by symmetry because the maximum distance it'll travel, the maximum displacement, will be at this turning point here. So, in order to find the turning point, what do I do? I've got S is equal to 0.6 t plus 0.4 t squared minus 0.2 t cubed. In order to find the maximum displacement, I need to differentiate with respect to t. So ds by dt can be equal to 0.6 plus 0.8 t minus 0.6 t squared. I need to solve this then when the gradient is equal to 0. So when ds by dt is equal to 0, I've got 0.6 plus 0.8 t minus 0.6 t squared is equal to 0. Again, I'm going to multiply it by 5, get nicer numbers. So I got 3 plus 0. Oops, not 0.4 t minus 3t squared is equal to 0. I'm going to multiply this by minus 1, so I can have a positive t squared minus 4t minus 3 is equal to 0. And I'm going to solve this. I'm going to have to use the quadratic formula. So using the quadratic formula, which you're going to use, you find that t is going to be equal to either 1.0 1.868 or minus 0.5351. Make sure you check that using the quadratic formula. Now, we know that t is going to be positive, so we can eliminate the negative answer, 1.868. In order to find the maximum displacement, then I need to sub that back into this equation. And so we've got S is going to be equal to 0.6 times 1.868 plus 0.4 times 1.868 squared minus 0.2 times 1. My writing getting smaller, 868 cubed. Now, if you store this in your calculator as ANS, then that would be even better. And once you calculate it, you find that S, the maximum displacement, is going to be equal to 1.21 meters from the child's hand, which is quite reasonable. Okay, so hit pause, make some notes, make sure you perform that calculation to check for t. Once you've done that, I've got some questions for you to answer. And questions for you are 11C. Let's start at 11C. Questions 1, 2, 3 up to 6. When you're ready, we'll move on to 11.4. Good luck.